All right, so I'm going to start with what they call the quotient identities, which is dealing with tangent and cotangent. What do you know about tangent already? What are you supposed to have memorized about tangent? Tangent is y over x. Well, yeah, now we know that's sine over cosine, because what else do we know about y and x? Well, we know that sine is the y and cosine is the x, so I could just substitute that in and say tangent is sine over cosine. Right, that's kind of where that comes from. And then vice versa, cotangent is the reciprocal of tangent. So if tangent sine over cosine, cotangent would be cosine over sine. Everybody okay where those come from? Does that kind of make sense, tied together maybe, hopefully? Sounds good. Now, the next one, let's think about rotating on a unit circle. So if this was a point on a unit circle that was at some x and y value, then we've looked at this already. Because I'm on the unit circle, I know the hypotenuse is 1. Oh, how far to the right did I go? Well, I went right x. How far up did I go? Right, that's for any x and y. So this is for any point on the unit circle. Doesn't matter where I'm at. So because of this, we could say, and just a quick reminder, if this is my angle theta, we could say that sine of theta would be equal to y over 1. That's where we get sine of theta is y. Cosine of theta would be adjacent over hypotenuse. So cosine of theta is x. Right? Everybody still seeing the whole picture? Now what about the Pythagorean theorem? Well, the Pythagorean theorem says x squared plus y squared equals 1. But if x is just cosine and y is just sine, then I could say cosine squared plus sine squared equals 1. Or rearranged, you most of the time see sine squared plus cosine squared equals 1. It's just the Pythagorean theorem using the fact that sine is the x value, cosine is the y value, to get sine squared plus cosine squared equals 1. All right, I don't know if they showed you this or not, but of the Pythagorean identities, right? You know, all of these identities that we're going over, you're going to have memorized. Okay? You're not going to be given these. So there are 3 Pythagorean identities. This is the only one I have memorized. I don't know the other ones. But I can show you how to discover them very quickly. Did they show y'all that? Or did they just say, here the 3 are? Okay. So for me, again, if I don't look at this paper, I can't tell you what the other 2 are right now. I just know this one. But in order to find the other 2, I could first divide all of this by sine squared. Sine squared divided by sine squared is 1. Cosine over sine. Cotangent. Right? And then 1 over sine squared. So we haven't went over these identities yet, but they're coming later in this packet. This is a reciprocal identity. So if sine squared is in the denominator, if I move sine to the numerator, sine becomes its reciprocal, which is cosecant. And you know that when we put this in our calculator, right, if you had to find cosecant of pi over 4 in your calculator, you would put 1 over sine of pi over 4, right? Because cosecant is the same thing as 1 over sine. So this should be another one of the Pythagorean identities. It may be in a slightly different order. It may be exactly like this. I don't know. No, okay, it's exactly that one. Okay? Sweet. So here's the second one. And again, I couldn't tell you this, but I know how to discover it. Divide everything by sine squared. So now, take a guess. How do you think you're going to find the second one? Or the third one?
Divide by cosine.
Divide everything by cosine squared. Because sine over cosine is tangent. Cosine divided by cosine. 1. And then 1 over cosine. Secant squared. So tangent squared plus 1 equals secant squared. There's the third Pythagorean identity.
What is the Q mean?
I don't have a Q. I don't have a Q.
What does theta mean?
These, some angle. I should have a theta right here. I left it off.
Yeah, that's what I was thinking Monday.
Yeah. The more we do these, you're going to see me. I don't write any theta there most of the time. I just normally write sine squared plus cosine squared equals 1. But it's just for any angle theta. And then it's the same angle theta. Okay, so to explain even odd, I'm thinking about all students take calculus. So let's focus first on sine. Sine is positive, positive, negative, negative, right? This is sine. So what they're talking about, let me just write what the identity is. This one is sine of negative theta equals negative sine theta. So just that on its own just seems like, I don't know, nonsense. But what they're saying is, what's a negative angle? That means I'm rotating in the opposite direction from normal. So if I rotate the opposite way, then I should get negative whatever I would get if I rotated in the positive direction. So for example, if I rotated negative pi over 4, that would put me here. Well, what is sine of negative pi over 4? Well, because I'm in the fourth quadrant, sine is negative. This is a 45, 45, 90, so it's opposite over hypotenuse. Right? This is sine of negative pi over 4. Okay? Well, what would it be if I rotate in the positive direction? Well, it would just be sine of pi over 4, which would be positive radical 2 over 2. So just make that negative. Whatever I would get if I rotated positive, it's going to become negative. Right? That's where that comes from. And think about it. If I rotate into the first quadrant, sine is positive here, but it's negative here. Opposite sign. If I rotate into the second quadrant, it's positive here, but it's negative here. Opposite sign. If I rotate into the third quadrant, negative and positive. Right? Go in the... You understand what I'm... Okay. Slow down, Cody. Slow down. If I let me start at the beginning. If I rotate in the first quadrant, sine is positive. If I rotated the opposite direction, that would put me in the fourth quadrant. And so they're opposite signs. If I rotated into the second quadrant normally, that puts me here. If I would have rotated in the opposite direction, that would put me in the third quadrant, which is opposite sign. If I would have originally rotated to the third quadrant, that would be negative. If I went the opposite direction, that would rotate me into the second quadrant, which is still opposite sign. And you see the pattern. That continues for every one of them for sine. So that's why sine and its reciprocal, cosecant, the negative comes out front. Okay? Now let's think about tangent and cotangent. So what are the signs of tangent? Tangent's positive in the first. Tangent is negative in the second. It's positive in the third. It's negative in the fourth. Now think about that same thought experiment. If I rotate in the positive direction, tangent would be positive. If I rotated the same angle but in the negative direction, it would be negative, opposite sign. If I would have rotated into the second quadrant, tangent would be negative. If I rotated the opposite direction, I would be in the third quadrant where tangent is positive. You see the pattern continuing. That it's just opposite sign depending on where I rotate. This is why tangent of negative theta equals negative tangent of theta, and cotangent of negative theta equals negative cotangent of theta. Okay, then lastly, let's focus on cosine. Cosine is positive in the first, negative in the second, negative in the third, positive in the fourth. So now what happens? If I rotate in the positive direction, cosine is positive. If I would have rotated in the negative direction into the fourth quadrant, cosine is still positive. So it has the same sign whether I rotate into the first or the negative direction, fourth. Continuing, what happens if I would have originally rotated to the second? It would be negative. Cosine is negative in the second. If I rotated the same angle but the opposite direction, it's still negative. So the signs match no matter which way I go. Right? I could get the same thing. That's why for this one, if I rotate the negative direction, it's the exact same as rotating the positive direction. That's what this one says. Right? If I rotate the negative direction of some theta, well, rotate the positive direction of that theta. I get the same thing because it agrees. Where the other ones are opposite signed. This one is the same sign. And the same follows for its reciprocal. So that's me explaining where it comes from. You're not going to have to do that. Okay? I like for it to make sense, that it's just not nonsense that's being thrown down. All that you really have to know is if you have a negative in the argument of sine, cosecant, tangent, or cotangent, you can move that negative out in front and drop it from the argument. If you have a negative in the argument of cosine or secant, it completely gets dropped. Right? It doesn't even matter. That's what you're going to be applying. Okay. Ready? But here it is in practice. All right? If I had secant in the denominator, I could move secant to the numerator and it becomes cosine. I don't know if you guys remember doing this. You would have originally learned like negative exponents. X to the negative second. If I move this to the denominator, it becomes 1 over x to the positive second. Right? Negative exponents just mean flip it to its reciprocal, and it would become positive negative. I think of these as the same way. I can move cosine, I can move any of the trig functions from numerator to denominator. But unlike this, we don't change the sign of exponents. We change the actual trig function we're using. So when I move secant across, it becomes cosine. And so vice versa, if secant was in the numerator, it could become cosine in the denominator. Right, if I moved it to the denominator. So all of the trig functions and their reciprocal, you have freedom to move them, numerator to denominator, as you see fit. But you have to change to its reciprocal identity when you do that. So sine would become cosecant, tangent would become cotangent, and vice versa. Okay, so did they go over like when I see this, I don't know for sure what is going to work, but I know I want a single trig function, which means right now I've got 2 trig functions. So anytime I see things that are not in terms of sine and cosine, the first thing I'm going to try is I'm going to write everything in terms of sine and cosine. That's the first option. I don't know that's going to work, but I bet it does here. So like if I focus on cosecant, how can I write that in terms of sine and cosine? Well, cosecant is 1 over sine. This is going to be multiplied by, what's tangent look like in terms of sine and cosine? So now I'm multiplying fractions. When I multiply fractions, I can cross reduce. So I've got a sign in the numerator, a sign in the denominator. Those just cancel out. So now this is 1 over cosine. We don't want to write it as 1 over cosine. So move cosine back to the numerator. Secant. So cosecant times tangent is secant. Why? This is why. Like, there's only so many different ways they can write these. Now, I can still choose the wrong thing to try first.
Because it's 1 over cosine.
But here's my thought process.
Or 1 over sine. So if you just KFC.
There's one of two things that could work here. I don't know which one it's going to be. You could try to write everything in terms of sine and cosine. That turns very ugly very quick.
Yeah, that's what I tried to do.
It may end up being what has to work. But that's not the first thing I would try here. Okay? That's allowable, but I'm going to try something else first that I think is a little simpler.
I've got 2.
Because the denominator is a binomial, it would be a lot simpler if I could quit making it a binomial. So, what we would do here, and again, may not work, I'm going to multiply by the conjugate.
I've got 2 in the numerator.
Do y'all remember conjugate? What's conjugate?
Conjugate acids.
I have no idea. That's not my specialty.
That's the thing, I remember that from last year.
Anybody remember?
It's the...
I did that too in the numerator.
And then you
I have
multiply
2 in the
the bottom. I don't know.
Okay. I switched the sign between them. Essentially, if I had x plus 2, I would multiply it by x minus 2. Because what happens if I multiply these parentheses? X squared minus 2x plus 2x cancels. When you multiply by the conjugate, that always cancels out. If you are going to fold it, which I hate, outside and inside cancels. And then you've got last.
So now we got, look.
So the same thing here, I'm going to try, and again, this may not work. I'm just trying something. I'm going to say this is not going to work. Now that I look at it. Because when I distribute the denominator, focus solely on the denominator, what would I get? I would get cosecant times cosecant, which is cosecant squared. And then this and this will cancel. And then I would have negative sine squared. Do we have a trig function that is cosecant squared minus sine squared? Is that a Pythagorean identity? There's not one that involves those. Okay? So, while this is the one I would try first, because I think it's simpler, it's not going to work this time. Because I can't simplify this any farther. Do you follow my logic? So, that's gone. Now I'm going to write everything in terms of sine and cosine. It's an ugly disaster, but somebody's got to do it.
I did that, but I think I did it wrong.
Let's start in the numerator. Cotangent is cosine over sine.
I think I got it.
And this is over cosecant. Cosecant is 1 over sine minus, I'm going to put sine over 1. Sure. So for me to simplify this further, this is almost a fraction divided by a fraction. Right? I see fraction divided by, if I could make this a single fraction, that'd make my life easier. So in the denominator, I want to simplify this to get a common denominator. So I can write it as one fraction instead of two separate as a binomial. So I'm going to go to the side and do some scratch work. What would be my common denominator for sine and 1? Sine would be my common denominator. Y'all are scared to say that, aren't you? So this used to be sine. I want it to be sine. How could I get from sine to sine? Multiply by 1. It already is there. This used to be 1. I want it to now be sine. How can I get from 1 to sine? So I have to multiply the numerator by sine. So sine times sine is sine squared. So now I have cosine of t over sine of t over 1 minus sine squared of t over sine of t. Now I've got a fraction divided by a fraction. One of these sticks out like a sore thumb.
That is.
I can simplify that. Whenever I see something being squared and it's a binomial, I'm automatically thinking Pythagorean identities. So what's my Pythagorean identity I have memorized? Sine squared plus cosine squared equals 1. This almost says this, but it doesn't. But can I manipulate the equation to make it say 1 minus sine squared?
You just move the sine over.
Just move the sine squared over. And it becomes 1 minus sine squared. So 1 minus sine squared is cosine squared. Which means, and again, I know this is a disaster, but I'm trying to record it because my next class needs to see this. So this is cosine over sine over cosine squared over sine. Now there's different ways that you can think about it from here, but I turn this into a 5th grade division problem because that's the only thing that makes sense in my head. So I'm going to write this as cosine of t over sine of t. And if I divide by this, that's the same thing as multiplying by its reciprocal.
Keep flip change.
Oh my gosh. Keep change flip. Y'all doing it backwards. See, what do y'all do? Y'all keep flip and then change in the middle? Y'all just go out of order?
No, you flip the sign.
You flip the sign. You change the sign. You flip the second fraction.
That's what I was thinking when we were doing it.
Well, y'all do whatever you want to do. I don't care.
But it just,
I think it's
it just,
Now,
it helps me remember.
as long as you remember, I don't care. From now, sine cancels. I have a cosine and a cosine squared. So I can cancel one of the cosines. This becomes 1. This is no longer squared. This is to the first. So this is 1 over cosine. 1 over cosine is secant. So this will be secant of t. And I was being such a good teacher this time, and I kept putting my argument. You see, I kept putting t. Well, I almost did. I didn't do it there. All right. The more that you do these, I don't really care what's in the argument. Like you see when I run out of room, I just know it's going to be t in the end. And so as I keep doing these, I don't write the theta or the t or the x. I just put it in my final answer. So what was the identity with cosine? If the argument of cosine is negative, I can just drop the negative, right? The negative doesn't come out front with cosine. With cosine, it just gets completely dropped. What about with sine and cotangent? It comes out front with both of those. So this becomes negative sine of x over negative cotangent of x. Well, what's a negative divided by a negative? So I can drop those negatives. So this is cosine of x plus sine of x over cotangent of x. Negative in the argument is always the first thing you fix. Every time. Every time, every time, every time. The other ones are all kind of debatable. But that one's a for sure. Now, I'm going to focus on this part because this is ugly, right? So I want to turn that into a fraction divided by a fraction for me. So sine is the numerator. I'm going to make that sine over 1. Over. What is cotangent? Cotangent would be cosine over sine. So now, whatever. KFC, whatever the junk. Multiply by the reciprocal. Sine times sine is 1 times cosine. So remember, this was just this piece, right? I simplified that piece to just have sine and cosine in it. I got rid of the cotangent. Well, now then, I've got a fraction. Well, I want to add fractions. So how can I add a fraction? I need to get a common denominator. So I could put the left term over 1. To get a common denominator, I need it to be over cosine. So how could I get, I can't just flip, I need to get a common denominator. It's 1. I want it to be cosine. So how can I go from 1 to cosine? Multiply numerator and denominator by cosine. Cosine times cosine is cosine squared. Now I have a common denominator, which is cosine. And the numerator is sine squared plus cosine squared. Well, that's Pythagorean identity. Sine squared plus cosine squared is 1 over cosine. 1 over cosine is secant. So this whole junk is secant.
These are kind of fun.
They're so much fun. I'm not going to do these all day.
I like it.
It's a different way to think, and you got to get your brain around it. But you're going to have a little bit of time to do that. But the difficult part is, like, people can normally get the hang of this, but they don't memorize the identities. For this first test, you have to have all of them memorized.
These 3 Pythagorean identities.
You need to know every one of those. Pythagorean identities, the
Even odd.
even odd, everything on that paper you have to have memorized.
We're gonna just memorize it. The whole thing.
But again, I showed you, like, I know them all. Besides, I don't know the Pythagorean identities. I know sine squared plus cosine squared equals 1. But other than that, I can discover the other ones if I need them.
How do we do it if it's saying it gives